We also have the chemoreceptor side, okay? So we detect pressure. Pressure is related to volume. We change things related to that. Ultimately, blood flow, perfusion, as we like to call it, taking blood and putting it through the tissues that need it, well, that is going to produce changes too, right? So what are our measures? This is at the organism level, okay? Not at the microcirculation, but it's going to sound like that, right? Cardiac CO2 levels that are increasing, pH that's decreasing, and O2 levels that are decreasing in the body, not in the tissue, in the body, okay? Detected by the chemoreceptors. Now, when would you have this? Easiest way to think of it is exercise, right? You suddenly got up, started running up and down the stairs, okay? You're consuming a lot of oxygen, you're producing a lot of acid, you're producing a lot of CO2. So what's coming out of your busy muscles, what's in the aorta, the big vessels, is going to be increasing CO2 levels, decreasing pH, and decreasing oxygen. All right, why do we care? Okay, so we have elevated, those things are elevated. The chemoreceptors detect that. We get two effects. One is on the respiratory tract, okay? Because in exercise, very quickly, we start breathing faster and deeper, right? Because we think of it as bringing in more oxygen, but what we're really doing is blowing off more CO2. Okay, so we get that. Respiratory rate and depth increases. That optimizes gas exchange. More on that in the respiratory chapter. In the cardiac chapter here, though, the chemoreceptors trigger a number of important things. It stimulates the heart, so our cardioacceleratory centers are stimulated and the inhibitory centers are inhibited, right? So we up the up and down the down. Vasomotor centers are also stimulated. So these effects give us increased cardiac output, increased blood pressure, right, from our increased total peripheral resistance. More blood pressure means that more tissues can get more blood flow. So if you couple that with the increase in respiratory rate, we're taking the extra oxygen that we're bringing in and the extra CO2 that we're getting out, and we're doing more with it, right? Because we are stimulating the heart, increasing the cardiac output. So this is like the exercise response. As we start to do exercise, our O2 drops and our CO2 goes up, our heart rate goes up to increase blood flow, and that helps provide more blood flow to the busy tissues and so on, right? All right. So these are happening all the time as well. Remember the chemoreceptors and how they're playing a role in basically increasing cardiac output and decreasing TPR enough to provide for the perfusion